the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in the binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No mic, no fame, just the sound we crave. Tune and turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just a vibe that's real. Faceless words you can touch and feel. In shadows, voices untamed. No need for spotlight, no claim to fame. Just a beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go.
David Sankoff is a highly influential figure, widely considered a founding father of bioinformatics and computational biology. His key contributions include pioneering dynamic programming for sequence alignment, foundational work in comparative genomics and RNA secondary structure prediction, and significant advancements in phylogenetics. He also innovated by applying statistical and computational methods to sociolinguistics. David Sankoff's early life began with his birth on December 31, 1942, in Montreal, Quebec, Canada. His foundational academic journey unfolded at McGill University, also in Montreal, where he meticulously pursued and earned his BSc, MSc, and ultimately his PhD in mathematics. Friesen, J.D. Sankoff, D.N. Simonovich, L. 1963. Radiobiological Studies of Vaccinia virus. Virology, 21-3, 411-424. Remarkably, this paper stands as David Sankoff's very first published academic work, appearing in 1963 while he was still an undergraduate student. Though not in linguistics or bioinformatics, it demonstrates his early engagement with rigorous scientific inquiry and quantitative methods, here applied to virology. It signals the nascent stages of a highly analytical mind capable of contributing to diverse scientific domains, laying the groundwork for a career characterized by interdisciplinary breakthroughs. Sankoff, D. 1970. On the rate of replacement of word-meaning relationships. Language, 46-3, 564-569. This early paper marks Sankoff's direct entry into quantitative linguistics, specifically addressing aspects of historical linguistics. In it, he explored the mathematical modeling of how semantic relationships between words change over time, a concept central to understanding language evolution. Sedergren, H.J.N. Sankoff, D. 1974. Variable rules, performance as a statistical reflection of competence. Language, 52, 333-355. This is a seminal paper that fundamentally shaped the field of quantitative sociolinguistics. Co-authored with Henrietta J. Sedergren, it formalized the concept of variable rules, a statistical methodology designed to quantify how linguistic features vary within speech communities and to identify the internal linguistic and external social factors influencing these variations. Sankoff, D. 1972. Matching sequences under deletion-insertion constraints. Proceedings of the National Academy of Sciences, 69-1, 4-6. This groundbreaking paper is a cornerstone of modern bioinformatics. In it, David Sankoff devised a quadratic time variant of the dynamic programming algorithm for pairwise sequence alignment, building upon the initial work of Needleman and Wunsch. This computationally efficient method provided the essential mathematical framework for comparing biological sequences DNA, RNA, proteins by accounting for deletions and insertions, thereby allowing researchers to identify similarities, infer homology, and understand evolutionary relationships at the molecular level. Sankoff, D. Morel, C., and Sedergren, R.J. 1973. Evolution of 5's RNA and the non-randomness of base replacement. Nature New Biology, 245-147, 232-234. This paper represents an early and crucial step in the development of computational comparative genomics and molecular phylogenetics. Collaborating with Robert Sedergren, Sankoff applied his nascent sequence alignment techniques to the study of 5's ribosomal RNA, developing methods for joint estimation of phylogenetic relationships and multiple sequence alignment. This work demonstrated how quantitative methods could be used to reconstruct evolutionary histories based on molecular data and highlighted the non-random nature of base substitutions, providing early insights into molecular evolution. Chvidal, V. and Sankoff, D. 1975. Longest common subsequences of two random sequences. Journal of Applied Probability, 12-2, 306-315. This highly influential theoretical paper, co-authored with Václav Chvidal, delved into the mathematical properties of the longest common subsequence problem, a core concept underlying sequence alignment, but in the context of random sequences. Their analysis yielded fundamental results regarding the expected length of such subsequences, leading to the identification of constants of proportionality now universally known as the Chvidal-Sankoff constants. Sankoff, D. and Poplak, S. 1981. A Formal Grammar for Code Switching. Papers in Linguistics, 14-1, 3-46. Building on his earlier work in quantitative linguistics, this highly cited paper, co-authored with Shana Poplak, provided a rigorous formal grammar for describing and analyzing code switching, the phenomenon where bilingual speakers alternate between two languages within a single utterance. Zucker, M. and Sankoff, D. 1984. RNA Secondary Structures and Their Prediction. Bulletin of Mathematical Biology, 46-4, 591-621. This paper, co-authored with Michael Zucker, provided a comprehensive review and further contributions to the then emerging field of RNA secondary structure prediction. It detailed the principles and computational methods for predicting the stable folded structures of RNA molecules, which are crucial for their biological function. Sankoff, D. 1985. Simultaneous solution of the RNA folding, alignment and protosequence problems. Siam Journal on Applied Mathematics, 45-5, 810-825. This is a seminal paper that introduced what is often referred to as the Sankoff algorithm for the simultaneous prediction of RNA secondary structure and multiple sequence alignment. Recognizing that sequence conservation and structural conservation are intrinsically linked, This dynamic programming approach sought to optimize both simultaneously. While computationally intensive, it established a gold standard for RNA structure prediction by explicitly considering covariation and provided a theoretical framework for more efficient algorithms that followed. Poplack, S. Sankoff, D. and Miller, c. 1988. The social correlates and linguistic processes of lexical borrowing and assimilation. In Linguistic Change and Variation, pages 47 to 104. This paper showcases Sankoff's continued engagement with sociolinguistics, exploring the intricate processes of lexical borrowing between languages and how newly borrowed words become integrated, or assimilated, into the recipient language. It delves into both the linguistic mechanisms and the social factors that influence these phenomena. Sankoff, D. and Rand, D. 1990. Variable Rule Analysis, a Quantitative Statistical Program. Computer Manual for Goldvarb 2.0. While not a traditional research paper, this manual for Goldvarb 2.0 is highly significant as it represents Sankoff's ongoing commitment to providing practical, robust computational tools for sociolinguists. Goldvarb, based on his foundational work on variable rules, became the standard software for quantitative analysis of linguistic variation. Sankoff, D. Leduc, G. Antoine, N. Paquin, B. Lang, B. F. N. Sedergren, R.J. 1992. Gene Order Comparisons for Phylogenetic Inference, Evolution of the Mitochondrial Genome. Proceedings of the National Academy of Sciences, 8914, 6575 to 6579. This paper marks a crucial point in Sankoff's shift towards whole genome analysis, applying his expertise in combinatorial optimization to compare entire gene orders for phylogenetic inference. Focusing on mitochondrial genomes, which have simpler organization. Blanchette, M. Bork, G. N. Sankoff, D. 1997. Breakpoint Phylogeny and the Evolution of the Ancestral Mitochondrial Genome of Placental Mammals. Genome Research, 75, 497 to 505. This highly influential paper, co-authored with Martin Blanchette and Guillaume Bork, introduced and applied the concept of breakpoint phylogeny to reconstruct ancestral mitochondrial genomes of placental mammals. By analyzing the conserved segments between genomes and the breakpoints where their order differs. Sankoff, D. 2000. The early introduction of dynamic programming into computational biology. Bioinformatics, 16-1, 41 to 47. This unique paper is a historical perspective written by Sankoff himself, reflecting on his pivotal role in introducing and applying dynamic programming algorithms to solve fundamental problems in computational biology, particularly sequence alignment. Eichler, E. E. N. Sankoff, D. 2003. Structural Dynamics of Eukaryotic Chromosome Evolution. Science, 301, 5634, 793 to 797. This highly cited review paper, co-authored with Evan E. Eichler, provides a comprehensive overview of the mechanisms and implications of large-scale structural changes in eukaryotic chromosomes. Sankoff, D. Taliamonte, S. N. Smith, E. 2005. Goldvarb X, a variable rule application for Macintosh and Windows. Department of Linguistics, University of Pennsylvania. This entry further underscores David Sankoff's sustained dedication to the field of quantitative sociolinguistics by highlighting the continued evolution of the Goldvarb software. Goldvarb X, released in 2005, provided an updated and cross-platform version of the variable rules analysis program he co-developed. Sankoff, D. and Trin, p. 2005. Chromosomal breakpoint reuse in genome sequence rearrangement. Journal of Computational Biology, 12-6, 812-821. This paper delves into a more specific, yet crucial, aspect of genome rearrangement models, the phenomenon of chromosomal breakpoint reuse. It investigates whether certain regions of the genome are more prone to breaking and rejoining during evolutionary history. Understanding breakpoint reuse is vital for developing more accurate and realistic models of genome evolution and for improving the precision of phylogenetic reconstructions based on rearrangement data. Sankoff, D. 2008. How to Predict the Evolution of a Bilingual Community. In Social Lives in Language, Sociolinguistics and Multilingual Speech Communities, celebrating the work of Gillian Sankoff, pages 179 to 194. John Benjamins. This contribution demonstrates Sankoff's continuing engagement with the dynamics of language change in social contexts, specifically focusing on bilingualism. In this paper, he explores theoretical and mathematical approaches to modeling and predicting the trajectory of language use within bilingual communities. Polly H. de Silva, Arash Jamshidpi, David Sankoff 2024. Sampling Gene Adjacencies and Geodesic Points of Random Genomes. Recom CG 2024, 189 to 210. This very recent paper demonstrates David Sankoff's ongoing and active contribution to the field of mathematical genomics. Presented at a leading computational genomics conference in 2024, it continues his long-standing work on the theoretical and algorithmic aspects of genome rearrangements. It delves into the statistical properties of gene adjacencies and geodesic points, shortest paths in the context of random genomes. David Sankoff is still alive. He continues his significant contributions to the fields of bioinformatics and computational biology. He remains active as the Canada Research Chair in Mathematical Genomics at the University of Ottawa. References: Anon 2017. ISCB Fellows. ISCB.org, International Society for Computational Biology. Archived from the original on March 20, 2017. Meisel, M. 2006. ISCB honors Michael S. Waterman and Matthew Blanchett. PLOS Computational Biology. 28, E105. Bibcode 2006 PLSCB.2.105M. doi 10.1371 journal.py.00201005. PMC 152, 6462. Sankoff, David 2008. How to Predict the Evolution of a Bilingual Community. In Meyerhoff, Miriam, and Naomi Nagy eds, Social Lives in Language, Sociolinguistics and Multilingual Speech Communities, celebrating the work of Gillian Sankoff, pages 179 to 194. Amsterdam, John Benjamins. Salle, Taliamonte, November 2, 2015. Making Waves, The Story of Variationist Sociolinguistics, Chichester, West Sussex, United Kingdom. ISBN 9781118455166. OCLC 9213072774. BMC Bioinformatics. Retrieved June 8, 2019. Journal of Bioinformatics and Computational Biology. Retrieved June 8, 2019. Molecular Phylogenetics and Evolution, Volume 43. Retrieved June 8, 2019. Sankoff, D. 2000. The early introduction of dynamic programming into computational biology. Bioinformatics. 16.1, 41-47. doi 10.1093 Bioinformatics 16.1.41. PMID 10812476. Friesen, J. D. Sankoff, D. Simonovich, L. 1963. Radiobiological Studies of Vaccinia virus. Virology. 21.3, 411-424. doi 10.1016.002-682263 PMID 14081366. Sankoff, David 1970. On the Rate of Replacement of Word-Meaning Relationships. Language. 46.3, 564-569. CiteSeer X10.1.1.667.3279. doi 10.2307 412307. Jaster 412307. Sedergren, H. J. D. Sankoff 1974. Variable Rules, Performance as a Statistical Reflection of Competence. Language. 52, 333-355. CiteSeer X10.1.1.665.3156. doi 10.2307 412441. Jaster 412441. Sankoff, D. S. Lauberg 1978. The Linguistic Market and the Statistical Explanation of Variability. In D. Sankoff ed. Linguistic Variation, Models and Methods pages 239-250. New York, Academic Press. Sankoff, David, Shana Poplak 1981. A Formal Grammar for Code Switching. Papers in Linguistics. 14.1, 3-46. CiteSeer X10.1.1.667.3175. doi 10.1080835181181093700523. Sankoff, D. 1972. Matching Sequences Under Deletion Insertion Constraints. Proceedings of the National Academy of Sciences of the United States of America. 69.1, 4-6. Bibcode 1972 PNAS.69.4s. doi 10.1073 NAS.69.1.4. PMC 427531. PMID 450-0555. Sankoff, D. C. Morel, R. J. Sedergren 1973. Evolution of 5's RNA and the Non-Randomness of Base Replacement. Nature New Biology. 245 147, 232-234. doi 10.1038 Nubio 2452320. PMID 420-1431. Chvital, Václav, Sankoff, David 1975, Longest Common Subsequences of Two Random Sequences, Journal of Applied Probability, 12-2, 306-315, doi 10.2307321-2444, Jaster 321-2444, MR 040-5531, S2 SID 2503459191. History of the Robert Sedergren Center. Retrieved August 25, 2013. Anon 2003. ISCB Senior Scientist Award to Sankoff. ISCB.org ISCB Awards. Archived from the original on March 3, 2016. David Sankoff. Research. Retrieved November 3, 2020. Pre-Akfas Therese Gwindekari Pre-Marcel Vincent before 2013. Akfas Pre in French. 2019 retrieved September 19, 2020. Professor Angela McLean awarded the Weldon Medal. May 17, 2018 David Sankoff, Excellence in Research Award. Archived from the original on September 24, 2014. Retrieved August 25, 2013. Co-founder of Bioinformatics to receive an honorary doctorate. Mathematics. June 11, 2019 retrieved November 3, 2020.
Mics on the floor where they drop like bombs. Faceless voices running all the cons. Digital whispers in a binary night. No light, no face, pure sound, no sight. Stories unfold in the dark unscrolled. Echoes of silence, secrets untold. Waves crash loud in this audio cave. No light, no fame, just the sound we crave. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Hidden in shadows, voices untamed. No need for spotlight, no claim to fame. Just the beat of life in a stream of thought. Every word a punchline, no need to be taught. Just listen close, no visuals needed. Raw conversation, unprocessed, unseated. Feel the pulse in every sentence said. No distractions, just thoughts in your head. Whispers of the streets, rumbling through. Faceless yet vivid, a world in view. No mic, just souls, connecting in flow. Pure and raw, let the rhythm go. Pure and raw. Pure and raw. Silence break, raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Tune in, turn up, let the silence break. Raw, unfiltered, hear the earthquake. No mic needed, just the vibe that's real. Faceless words you can touch and feel. Pure and raw.
Okay.